Okay, so we're getting into Unit 12, and if you thought we were over circles, we're not. But we are not going to be talking about arc measures as much. We're going to be talking about line segment lengths. And specifically in 2.1, we're talking about chords and the lengths of chords. If you remember, a chord is a line segment within the bounds of the circumference of a circle. A chord is made by a secant passing through a circle, and that part of that secant that is within the confines of the circumference is the chord. And if it just so happens that the secant passes through, or the chord passes through the center point, that chord is the diameter. Anyway, so there's three main topics that I would like to talk about, or three main relationships that I would like to talk about in 2.1. One, I'd like to talk about the chord perpendicular relationship, the perpendicular chord relationship, the equidistant relationship, and the the segment interception relationship. So anyway, let's get to that. Okay, let's talk about the perpendicular relationship. Okay, so if I have a diameter, okay, if I have one of the chord is a diameter, like we talked about just before that, we'll say it's, AB at circle C, right? AB. Okay. If the diameter of a circle is perpendicular to the chord, right, so then the diameter of that chord bisects the chord. Okay, so what does that mean? All right, so this is my diameter, okay, and then this chord comes in, and it's perpendicular to it. If it's perpendicular to it. All right, so this is a 90-degree angle, and let's call this chord, call it X, Y. That is my chord. Okay, so if I have a diameter is one of my chords, and the other chord is perpendicular to my diameter, then this chord is bisected by my diameter. And that means that I got my blue one, that this line segment and this line segment are equal in measure. They're equal in measure. So what does that mean? How does that help us? Well, that can help us in a number of ways. We're going to call this line, we'll call this point P. Call that point P. Let's see, point P here. That can help us in a number of ways, right? So what they can do is they can give us a variation of things. They can give us a variation of givens, okay? But with any of those variation of givens, we can draw triangles, because that's a 90-degree angle. Let's draw three variations of triangles. Let's draw this pink triangle, like from here to here. Let's draw this blue triangle from here to here. Let's draw a what other color triangle can I draw? Let's draw a green triangle from here to here. From here to here. All right, so we have three. I can't see that triangle very well, can you? I guess I'm going to use my brighten it up a little. Nope. I'm gonna use this one. Use this one, my green triangle. Oh yeah, there we go. Got a green triangle. Okay, so they can give us a variation of line segments here, and each variation, I can play around with Pythagorean's theorem, right? Because each one of these, this is a hypotenuse, this is a hypotenuse, and this is a hypotenuse. This is a hypotenuse, right? And each one of these is a long leg, right? This would be a long leg. From here to here is a long leg. This is a leg. This is a leg. This is a short leg. This is a long leg. This is a long leg. This is a short leg, right? This they could give us is an entire length, right? Since this is the midpoint, we know that this is half of that entire length. They could give us a diameter, right? And we know that from here to here is a radius, right? So we could be like, okay, we'll solve for this, and they just give us this part, right? So lots of different things. They could give us a central angle measure, right? And just give us this arc measure. They could give us a perimeter, or they could give us a central angle and a radius and circumference. They could give us all sorts of different crazy stuff just to solve for something as simple as that, right? So it's important that you put a lot of this stuff together just to solve and understand this simple relationship. Okay, you might have to figure out a bunch of little crazy stuff, right? So maybe this is like maybe they bisect this thing into smaller stuff over here. Okay, so they can break that down in all sorts of different crazy things just for you to solve for something simple. Pythagorean's theorem doesn't go away, right? So these are legs here, and legs there. Okay, so lots of different things that they could use to put this work to exercise and combine it with other things. Okay, another thing they might have you put to work is if you have two chords that intersect, their products equal the lengths of their segments. So what does that mean? So let's have two random chords that intersect. Let's say chord, let me use bigger. I have chord blue and chord green. So I have chord blue from here to here, for instance, and I'll have chord green. We'll do it from like here to here. Chord green. Two random chords that intersect. And we'll call this one BL for blue, and we'll call this one GR green, point GR, point B and L, and they intercept at point P. They intercept at point P. They intercept at point P. Well, if I want to figure the relationship between these line segments, look like this. The relationships are the short line segment and the pieces of the line segment. So B, P, so this part of the line segment times P, L, the rest of the line segment, equals short line segment part, GP, times, you guessed it, PR. Every time. Okay, so this one, what they'll end up doing is give you some variable statements for like this line segment, and a value for this line segment, and a variable statement for this line segment, and a value for that statement. And you'll have to plug some stuff in and solve for X. I'll show you some examples here toward the end of this. Okay, so this one's pretty straightforward. Not too crazy for this. You know, maybe, I don't know. I can't really think of anything we could do real crazy with this. They could maybe somehow figure out how to combine the arc relationship with these angles somehow, and then maybe like a law of sines somehow, because I think that these would be similar triangles, because they would be similar triangles, I believe. So, because the angle measures would be the same. So that would be kind of neat, right? So maybe we could figure out something like that. But aside from that, that'd be like really stretching it. But anyway, because I believe that this and 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 this, I believe those are all similar line segments. But I think that's way beyond the scope of this class. Anyway, so let's move on to the last relationship, which is equidistant chords from the center, and they are congruent. All right, so if I have like a chord like this, for instance, let me do my best here to like give you a good example, like this chord, and then like I think it's the one that mirrors this, would be like this chord here, and like this chord. That's kind of close, not really though, right? If they are, let's just say for instance they're equidistant, okay, this distance and this distance are equal, then that means that these are congruent. So that means that every point in its respective point is equal to its counterpoint on the circumference and its counterpoint from the center, right? So what they'll do here is they'll say, hey, this line segment equals this, and this line segment equals that, you know, and then you'll set them equal to each other and solve, right? Or maybe give you arc lengths, right? Something like that. Who knows? So let's take a look at some work, and we'll work through those things. All right. So step by step here. Let me zoom out a little. Okay. So here's some homework questions. So don't copy these down in your practice work because they're not the same. Homework questions are, all right, first step of the process is done. We have a drawing. So the second step of the process is to mark it up with our givens. So TS is 12x plus 5, 12x minus 5, excuse me, and MK is 8x, 8x plus 13, 8x plus 13. So we got to figure out what the value x is, and what the length is. Well, this is telling us that these two angles here are 90 degrees. That's just showing us that those are equal in length. Those are congruent lengths. So MK and TS are equidistant from G. Whenever you see something like that, it shows you that those chords are equidistant. Okay. So since these are both perpendicular, right? They're equidistant. Okay. So anyway, so they just said, and these are congruent, right? So it's going to be simple as 12x minus 5. I give a neutral color equals 8x plus 13. Right? So combining like terms, nothing really to combine on either side. So I'll take my 12 is positive, so I'll bring 8 over here. So it's going to be 4x equals 18. So 18 divided by 4 is 4.5. X equals 4.5. Now I'm going to plug this 4.5 equals, 4.5 times TS is 12x minus 5 equals 12 times 4.5 equals 54. TS equals 54. Okay, so let me pause that for a minute. I forgot to subtract the 54, so it's actually 49. Oops, equals 49. All right, so there you go, there's that one. Okay, our next one is our, well, first let's go ahead and follow our process. Okay, our process is RJ is 4y, and then we have RX, JX is part of the same line. JX is 3. And then we have PJ. PJ is 2y minus 2. And JW, blue, is 8. Alright, so that is the first step in our process. I skipped a step in our last process, shame on me. Alright, so our next step in the process is to write the equation, and write an equation in terms, recognize what we got, what relationship there is going on. So the relationship we have is two chords intersecting within a circle. So we know that the two portions of those chords multiplied together equal each other. So we have PJ line segment times JW line segment times JW line segment equals, shifting to green, XJ times JR times JR. Oh, how did I put another one there? Times JR. Okay, so the two different pieces of the line segment multiplied together equal each other. Now product of the pieces. Product of the pieces. I just thought of that. I don't know if that one's going to work. All right, so now I'm going to substitute. Substitute, so 2y minus 2 times 8 equals 3 times 4y. Okay, now I can just go ahead and I'm going to go ahead and make this 16y minus 16 equals 12y. And over here, carry that on to, well, 4y equals 16. So y is going to equal 6. Awesome. All right, so then I'm going to go 6 times pj was 2 minus 2 times y minus 2, so that's going to be 2 times 12 is going to be 10. Oh, wait a minute. Oh, no, wait a minute. That's not 6, that's 4. That's 4. This is 4. What am I doing? I jumped way ahead. This is 6. All right. Now, final length PW. So this is 4 PW. PW equals 2y. I could even go so far as by saying pj plus 8, but I don't think I need to do that. So 2 times, it's supposed to be blue. 2 times 8, or times 4, minus 2, plus 8. Plus 8. So 2 times 4 equals minus 2 equals plus 8 equals 14. It's going to equal 14. It should be green. Green 6. All right, so there's that one. Okay, now here is another one. Let's see if it's challenging. CR is 13x, KR is 15x, and KR is... that's not really challenging. So this, I would like to use, anyway, I have to do triangle stuff with. Here's one I have to do triangle stuff with. Here's one, I'll do both of these, I guess. Okay. So this one, let me go ahead and CR is my blue one. CR is 13x plus 5. KR is 25x minus 1. And what do I know about the relationship? Let's write in. I know that these are equal. Okay. So I know that CR in general terms, that CR equals, well, let me write this in a better way, that KR divided by 2, and it's half of CR equals CR equals CR, right? Because CR is 1/2 of, or KR, excuse me, KR is 1/2 of CR, right? If I took CR, KR, I divided, no, that's not right. That's not right. I gotta change this. That's why I always talk it through. If I double KR, I get CR. That's a better way to put that. Yeah, so if I double KR, I get CR. There we go. That is right. That's why I talk through this stuff with myself. All right, so now I can plug in some numbers. Okay, so now I get 2 times 25x minus 1 equals 13x plus 5. That's 50x minus 1. It's going to be equal to 50x minus 1 equals 13x plus 5. Alright, so I'm going to take the 13 over here and subtract it. So it's going to be 50 minus 13. 50 minus 13 equals 37x. 37x equals, and then this is going to go over to here, and it's going to be, let's see, 6. 37x equals 6. No, sorry, 2. I forgot to do the 2 there. Equals 7. 37x equals 7. Seems weird. Okay, equals 7. Equals 7. So x equals 7 30-seconds. Equals 7 30-seconds. This is 1.8. No, correction. 0.189. 0.189. That's weird. Let me check the thing. Yep, that's what the book says. All right, so that's 0.189. So what's the length of chord CR? So chord CR is going to be 13. So 0.189 times 13 plus 5. Okay, so 0.189, 0.189 times 13 equals plus 5 equals 7.54. It's approximately 7. Let's say round to 7.5. Approximately 7.5. Okay, one more, and we'll call it a lesson. All right, so here we have, this is what I was talking about with right triangles. We have a right triangle, and this sits on a diameter, because circle B is named circle B, so that's the center point, and this chord runs through the center point, so this is a diameter. It also says it's a diameter right there, diameter JP. Okay, and it's given that CM is 30. CM is 30. So CM is 30. And since CM is 30, I know because this is bisected, because that's a thing, that means that this is 15. I'm going to go ahead and just label that because that's one of the things that I know. Okay? And TB is 8. So this is 8. It's a portion of this, so this is 8. Okay, so that's 8. What is the length of BP? I'm trying to solve for that. All right, so let me write an equation to to solve for this. All right, so what is something that I know? Right, I know that JB equals CB. Right, and why do I know that? Right, I know that because CB and JB are both a radius of the circle. All right, so, and I know that the diameter, well, I know that, oh, look at that, that's a hypotenuse. That's a hypotenuse. And I know that CB is going to equals the square root of 8 squared plus 15 squared. Oh, this isn't as hard as I thought it was going to be. All right, it's asking for the BP. It'd be better if it was asking for the diameter. That's all right. So 8 squared plus 15 squared. 8 squared. Let's restart this so you can see. 8 squared plus 15 squared equals square root 17. CB equals 17. This is 17. So this is 17, which equals BP. BP, which equals 17, which also equals BM. Also equals BM. Also equals BZ. Also equals BW. Also equals BP. Okay, they're all 17. Okay, so hopefully that worked out for you. Told you guys Pythagorean's theorem wasn't gonna go away. I hope you guys learned from this one. I liked it.